Hi, I'm Rogan Tokach with the Auburn University Bee Lab, and I'm here to talk to you about one of the really cool projects that we're doing this year, which is the winter capped brood monitoring study. So the kind of background on this study is my advisor, Dr. Jeff Williams, in the November of 2021, went out to some of his colonies after a cold snap and noticed that he had almost zero capped brood area in any of his colonies. He then went out in December and January and peeked in his colonies again, and noticed that he did have some patches of capped brood. And this is a time point where a lot of beekeepers in Alabama think that they experience a full brood break. And so that really brought up the question, well, do beekeepers in Alabama experience a full brood break? What's the duration of that brood break? And how can that be beneficial, and potentially could beekeepers take advantage of that? And so what this study is that we're looking for capped brood area throughout the winter season. So we have collaborators from 23 different USDA, beekeepers, and different universities partnered in this study in a bunch of different areas. And so what we're really trying to do is we're trying to determine when colonies potentially go broodless. And this is really important because beekeepers can take advantage of these time points and use oxalic acid treatments to treat against the Varroa destructor mite. And so we know that oxalic acid is not very effective when there's a lot of capped brood in the colony. However, when you have times of a brood break, oxalic acid is very good at killing mites in the dispersal phase when they're feeding on adult bees. And so the goal of this study is really to try to determine the optimal time point to do some of these oxalic acid treatments in different regions. So every 2 weeks, all of our collaborators go out and we assess colonies, and what we're looking for is we're looking for capped brood area. So all of that data is compressed and summarized, and then we publish different maps showing the different amount of capped brood in each different region that our collaborators are in. So now that you know a little bit about the background of the study, let's get into some of the colonies. So we'll start by removing the lid. And what the initial thing that we do with these colonies is that we assess how many frames of bees there are on the tops and the bottoms of each box. And so when I'm looking at this, I'm seeing 1, 2, 3, 4, 5, about 5.5 frames of bees. Now I also do the same thing on the bottom. And so when I'm looking at the bottom, I'm seeing 1, 2, 3, 4, about 5 frames of bees on the bottom, maybe 4.5. Now I do the exact same thing with the bottom box, looking at the tops and the bottoms of the frames. So really on this one, you're only seeing about maybe 3.5 to 4 frames of bees. And so this just gives us some baseline information on overall colony strength. And again, I look at the bottom, and you can see there's hardly any frames on the bottom. And so you can see that primarily most of the colony and most of the bees are in that top box. And so that's likely to be where most of the brood is as well. So if I was doing a full inspection, I'd go through and double check that we don't have any brood in any of the frames on this bottom box. But since I'm only doing a quick inspection, I'm only going to be going through the top box today for you. So now I'm just going to be opening up this colony and removing that first frame. And of course, you're probably not surprised that we have a little bit of honey, but no brood on it. So breaking in, I'm going to take out another frame, and still no capped brood, or we do have a little bit of capped brood on this side. So on this option, we really only have on our data sheet 1 to 5%. So I would probably say that this fits that 1 to 5% of the frame category. So now you can see on this frame that we do have some levels of capped brood. And so what we're doing is we're assessing and trying to determine how much of the frame percentage is covered in capped brood. And so this is a little bit difficult because it's a little bit spotty. And so I would say generally that this is somewhere around 25 to 30% capped brood. Then on the back end, you see that we do have some open cells with some larvae, but this is maybe probably only 5 to 10% capped brood area. So put that frame back and we'll take out the next frame. And on this side of the frame, you see that we have only that 1 to 5% capped brood area. And on the back, this is probably, again, somewhere around 5 to 10%. Maybe, probably a little bit less. And then we'll look at this next frame. And we don't see any capped brood. And generally that means that there's probably no more capped brood left in the colony. So in a full inspection, we go through the rest of these frames and make sure and probably zero it out. And that's really all we're doing. Is then this colony, we see that we have some capped brood area. And so that's the data that we'll put down that will then be put onto a map that then you can see how much capped brood area there is per colony on average.
So now that you know a little bit more about our data collection process, let's look at the final product on our brood monitoring website. So here's our 2024-2025 Winter Capped Honeybee Brood Monitoring Program website. And you can access this website by typing in aub.ie/winterbrood. So these are the maps that Dr. Stephanie Rogers in the GeoIdea lab puts together for us, and she's in the geoscience department at Auburn University. So here you can see this is the map from the week of November 21st of 2024. Now these circles correspond with the average deep capped brood frame equivalents. So as you can see, this spot right here, this is representing Auburn, and we had somewhere between 0.31 to 1 frame of brood per colony, and that's just the average. But you can see in some other areas like Starkville, Mississippi, in southern Alabama, and then over for University of Florida in Gainesville, they had over 1 frame of capped brood at this sampling period. Now, as you scroll down, you can also see this was 2 weeks previous in the week of November 7th. You see Starkville, Mississippi still had quite a bit of capped brood, but these other areas, interestingly, looks like they had less brood in some of these areas compared to the week of November 21st, which you wouldn't really expect to see. But this is really why we're trying to do this project, because we're trying to figure out when you're seeing these low capped brood points. Now, the other thing I want to point out is some of these X's. So you can see this spot in South Carolina, over here in Virginia, and then up near Washington, D.C., they had no capped brood. And so that was really interesting to see that earlier in the season, they're not seeing any capped brood. And even in October, in some areas in Virginia and South Carolina, there was no brood in any of these colonies. Now, as we scroll back up, there's a couple really other cool things about this website. For one, you can look back at the static maps from previous years. So this is our 3rd year with the project. And if we click on this link, you can see this takes you to the 2023-2024 Winter Capped Honeybee Brood Monitoring Program website. So as we scroll down, we can see biweekly static maps, and if we go all the way to the bottom, you can see that we started in mid-October. And it's really interesting as you scroll through, you get to see the changes over time in some of these capped brood areas. So as we go through mid-November, we're starting to see a little bit of a decrease in overall capped brood. And then at the end of November, you're starting to see quite a few different X's pop up. So those are points where you're seeing no capped brood. Now, as we move into mid-December and then the end of December, this is really when we're starting to see very little capped brood in some of these colonies. But still, in some of these southern regions, you're still seeing that they have over a frame of capped brood. Now, I think that January was probably our low point in 2024 of capped brood area. But as you scroll up further, you see that eventually it starts to bounce back, and then in February you start to see a lot of capped brood again. So when you're looking and thinking about management plans, in somewhere in between late December and early to mid-January, that would have been the most opportune time for at least Auburn beekeepers to treat for Varroa mites using oxalic acid, because that's when they're going to have the least amount of capped brood. Now, if we toggle back to the main screen, there's a couple more things on this main website that you can look at. For one, this is our dynamic web map. So Dr. Rogers has done a really good job of putting this together, and it's really exciting because you can compare over weeks side by side. So as we look on this key, we can unhide the November 7th data, and we can see that you can see the different averages between those two different dates. So take, for example, somewhere like Starkville, Mississippi, you see that easily that on November 7th, there was more capped brood compared to the November 21st sampling date. You can also unhide the October data as well, and you see that in general, there was more capped brood on October compared to the November. Another really cool thing as we open up the 2023-2024 data is you can compare across years. So if we look at, this is November 21st of 2024, but we can also see November 30th of 2023. So you can compare those two different sites. So if we look at, in comparison with Auburn, it looks like Auburn had about the same amount of capped brood in 2023 as they did in 2024. The last really cool thing about this website is you can click on individual points, and as we move this key away, you can see, and it will give you the averages of each and show each individual colony data. So on average, Auburn colonies in November of 2024 had 0.82 frames of capped brood. The other really cool thing is that you can look all the way down at the bottom and see the brood averages over time. So you can hover over the bar to see the values. And so this is going all the way back to the first year of data collection, which was the 2022-2023 season. So as we go through, you can just see that decrease, and in 2022-2023, you saw that the lowest amount of capped brood was in late December of 2022. And then you see that the colonies started to ramp back up, and by February, they had over 3 frames of capped brood. Now you can see that the process started all over again in October of 2023. And you see that again, you go down and you're going down. And then in 2024, you see that you're starting to bounce back up. But what's really interesting when you compare these two side by side is that in the 2023 year, you see a really rapid growth of capped brood, but you see a much more gradual growth in 2024. And so now, finally, as we move back to the main web page one last time, we have this survey that we're asking beekeepers to fill out. And so what this is we're asking beekeepers if they use the maps to make an informed decision about chemical Varroa treatments in their colonies. So this is really important information and helps us provide information to different grants and funding agencies that beekeepers are really using this information to help make these informed decisions that help them with mitigating colony losses and treatments.
So our goal with this project is really to be able to allow beekeepers to optimize some of their Varroa mite treatments, specifically with oxalic acid, and really prevent colony losses due to Varroa mite pressure. So now that, thanks for watching our video. We'd like to thank all of our collaborators that are in on this project, Project APIS-M, the Southern IPM Center, as well as the USDA ARS and USDA NIFA. Thanks for watching this video, and please stay tuned for some of the awesome other research that's coming out of the Auburn University Bee Lab.